Hi, this is Mrs. Vaughn, and I want to give you some examples with the special segments and circles. So our first example is when the two chords intersect inside the circle. So our formula is going to be this segment times this segment is equal to this segment times this segment. So for example, I'll write that out. Here's my circle. So A times B equals C times D. Okay, so we've got 9 for our AE, so we'll label our triangle, our circle, because it's easier to work when we see it. I recommend that you draw these out on paper. So DE is 5, and BE is X. So we're solving for BE. So I'm going to write 9 times 4 equals 5 times X. 9 times 4 is 36 equals 5X. Then we're going to divide both sides by 5. And so we get 36 fifths. And our decimal, 36 divided by 5 is 7.2. If I go too fast, just pause it, slow down, but make sure to use this formula when you are doing these kind of examples. And remember, the two that you multiply together are on the same chord. Okay, and then the CD, they're on the same chord, but you multiply them together. All right, with this example, notice the x plus 1 and the 4 are on the same line, so I'm going to multiply those together. So 4 times x plus 1 is equal to the product of the x plus 5 and the 3. So 3 times x plus 5. So here I'm going to distribute. So I have 4x plus 4 equals 3x plus 15. Subtract the 3x from both sides of the equation, and I get x, and then I'm going to subtract the 4 from this side to get 11 over on that side. So think about it, 11 plus 5 is 16 times 3. That should equal 11 plus 1 is 12 times 4. And so 16 times 3 is 48, and 12 times 4 is also 48. All right, that's when your chords are going to cross inside the circle. We're going to multiply each part on the same line, with each other, and it's going to equal to the product of the other chord segments. Okay, so my next problem, I have two tangent lines, and they intersect outside the circle up here. And whenever our rule for tangents, when you have two tangents that intersect outside the circle, and they go to the same circle, those tangent segments are equal. And so I know that that segment is equal to that one. So when I write my equation, I get to set them equal to each other. Okay, so it's 3x plus 7 equals 5x minus 9. So I'll subtract the 3x from both sides. If you have a calculator that solves for you, once you've written this equation, you can just put that in the calculator and solve for it. But I like to show you the work so that you actually get in the habit of doing it or know how to do it when it comes time. So we have 2x. We're going to add 9 to both sides. 9 plus 7 is 16. Divide both sides by 2. And so my x value is 8. And that's because this tangent segments are equal. Okay, this is when we have a tangent and a secant. Okay, so the formula for this is it's the tangent squared equals the whole secant segment times the exterior segment. Okay, so that would be the tangent squared equals the whole segment. So that whole thing is going to be equal to x plus 2. So we're going to go x plus 2 times just the exterior part. All right, and then we can either punch this into the calculator. This is important. This is that you know the formula. So we have 16 equals 2x plus 4, because I distributed it this way. I'm going to subtract 4 from both sides, and I get 12. So x equals 6. So 6, 7, 8. The whole thing's 8 times 2 is 16. That's going to equal 4 squared, which is also 16. Okay, here I have two secant segments. And what we're going to do is, this is the whole times the outside times equals the whole times the outside, or the exterior. That's what I put in my notes, is exterior. Okay, so what is the whole length of the segment? Well, the whole thing here is 12 plus 4, which is 16. And this whole one is 5x plus 5, or 5 plus x, so x plus 5. Okay, so remember, we add them together when we're trying to get the whole thing. So we're going to do the whole side, 16, times just the outside, is equal to the whole side times just the outside. Okay, so we have 16 times 4. 16 times 4 is 64, equals 5x plus 25. All right, so we just need to subtract 25 from both sides. 64 minus 25 is 39. And then we're going to divide by 5. We get 39/5, or 7.8. for x. So the distance from this point to this point, this chord, is 7.8 long. All right, let's look at the next one. Okay, here I have two lines that are tangent, and one of them's called x, so that means this one is equal to it, so it's also x. And the radius is 8, and then this segment here, which doesn't go all the way through, so it's not even a secant segment. Okay, so what I'm going to do is remember that the radius and the tangent line, they're perpendicular. And so that means I have a right triangle. And so when you have a right triangle, you get to use the Pythagorean Theorem. And we all remember that c squared equals a squared plus b squared. Okay, so my c is always the one opposite of the right angle. So that one, oh well, it only says it's 9 to here. But I know that the radius is 8. So 9 plus 8 is 17. Okay, and then my a and b can be either one of the other legs. So we'll just say 8 squared plus x squared. Okay, 17 squared is the same thing as 17 times 17, that's 289, equals 8 times 8 is 64. All right. So my next step is to subtract 64 from both sides. 289 minus 64 is going to be 225. Do you recognize that as a perfect square? Let's take the square root of that, and I think it's 15. And it is. So again, we're taking the square root of both sides, and we get 15 equals x. So that means this, this segment and this segment are both x. Another way that we could have done this is added this other radius to go the whole way, and so our diameter would have been 16. So this would have been 16, and 16 plus 9, the whole thing, times the outside, would equal x squared. So 16 plus 9 is 25, and 25 times 9 is 25 times 9 is 225. And when I take the square root of that, I end up with the same answer. So either way works. Well, that's the end of the example problems. I hope that they helped you, and I hope that if you need to go slower, that you pause the video. Please make sure to contact me if you still need help. And thanks for watching.